I'm Joe Andaverde. Let's see, we're going to talk a little bit about how we do infrastructure automation here at Temporal. A little bit of background about me. I've been doing infrastructure automation for a while now. I worked at Hashicorp on Hashicorp Cloud Platform for, just a little over a year. Got from pre-beta to GA in that period of time on Azure and AWS. And so in that time, picked up quite a few tricks and wanted to share some of that. Brought that along with me to here at Temporal, and it's how we're provisioning infrastructure. I think for what it's worth, we use a combination of Terraform and typical like SDK calls to provision infrastructure, because there's some things have Terraform providers, some don't. Many do, actually, and so we have a combination of those things. One of the motivations, before we dive into this deeply, for using the Terraform providers is just that rich ecosystem that that Terraform and Hashicorp has amassed with respect to the providers. If you're not familiar with what a Terraform provider is, because the word seems quite a bit overloaded, a provider is a library, if you will, or a set of code to perform actions against a service: create, read, update, delete. And the Terraform project will transform some HCL, the configuration language, into calls to that provider. So, and then it handles sort of the relationship between resources and the directed acyclic graph that decides what order to create things and pipes values around. So if you're not familiar with that, go check out more. Hopefully I can give you an idea of how it might be valuable and how that works with Temporal in this talk. So as I said, I bring a lot of this experience from my time at HashiCorp. We were provisioning resources on AWS and Azure using Terraform. So I don't know where exactly things are today, but I do know when I was there, this was one of our primary mechanisms for provisioning infrastructure. Of course, there's a whole lot more that goes on besides just provisioning the resources. There's managing them, lifetimes, things that also Temporal is very good at doing. But today we're going to focus really on just provisioning the infrastructure. So I think, we started with some pretty simple proof of concept here at Temporal. As you know, we're a startup, and you do what you need to do in order to sort of get down the road. We are now all automated. Our infrastructure is automated, and yeah, these are some of the learnings and why we did it. So let's jump into a quick overview of what you're going to see here. So we're going to go through a code demo, and this code demo is available on GitHub. And the general architecture of what we're talking about here is that you've got a workflow that handles something, and this workflow can be quite long, right? You can provision hundreds of resources throughout a single workflow, and then within each activity, you can provision some subset of those resources. Now, that could be one, that could be two. I typically like to keep that pretty low. You want to think about, with activities, like where your logical breakdown of your resources in your infrastructure. For example, what we're going to do today is we're going to create a network, a VPC, and we're going to assign subnets to that network. And the one logical way to think about that is that you can create the VPC separately and then create the subnets as a separate step. And then you imagine just gluing these things together over, a fairly complex infrastructure. And then you get all the benefits of orchestrating these different infrastructure inputs and outputs from Terraform and from activities, and orchestrating them all together to make just an amazing infrastructure experience. It's been my experience, at least. So the goal of each activity is for it to be retriable, and we do some work inside of that activity to to think about how we can make it idempotent. So for example, if an activity for whatever reason gets canceled or gets killed in the middle of the process, or gets terminated for any reason, you want to be able to pick up where you left off, right? So activities should be written in a way that allows you to deal with transient errors. Whether, one big source of problem that you could probably imagine, may not typically think of as a problem, but let's say you're rolling out all of your workers, you're re-rolling them, or you're terminating a pod, but it's executing an activity at that moment. So you want to think about your activities as idempotent, and you want to make them so that every run of the activity results in the same thing. That's another way of saying that. So what we have here is some demo code that wraps, that handles some of that, the details of what it means to be inside of a temporal activity. So as you know, activities have some amount of heart beating that needs to happen. So that, if they've gone rogue, they've stalled or whatnot, or, simply just aren't responding, then if they're not sending out a heartbeat, the temporal is going to schedule that activity to get run again. And so what we want to do is that, and because of the way, if you go down a couple layers here to Terraform execution, we're going to shell out to Terraform. And if you actually look at the Terraform CDK, from my experience at least, or from what I've seen, it does similar things, though it kind of skips the HCL language. So the Terraform CDK also shells out to Terraform, and it seems to be, kind of the way things are now. Though in the future, who knows where this will go? Like if you're still going to be shelling out to a binary, or if you'll be able to do this stuff in process. So we've got this activity wrapper that understands heart beating and cancellation of an activity. And then we've got the Terraform workspace, which is responsible for getting our Terraform files into the right spot, providing the right input variables, mapping, from activity inputs to our actual Terraform execution. And then, of course, authentication with our cloud provider, or whatever particular cloud, provider, Terraform provider we're using. And then the next layer down is a Terraform execution. And this just handles the signals. Like, so if your worker gets canceled, we want to be able to give Terraform the opportunity to save its state and exit nicely. Because if it doesn't, that could be pretty unfortunate, because state may not be persisted. And so your infrastructure will be inconsistent with what Terraform thinks. Now we try to mitigate some of that issue, which going back to making this idempotent and making the goal retriable by importing resources prior to trying to create them. And I think if you keep this small, this could be quite manageable. One of the big use cases that I could think of that one of the first things that, of course, we run our infrastructure on Kubernetes, is that we had used this massive Terraform EKS module, and it provisions IAM, it provisions node groups, creates launch templates, and it does a whole mass of things. And I don't think I can name a single person that I've ever met that have used that and had a good experience. Particularly because the module is extremely complex, and if one aspect of that goes wrong for whatever reason, or you're trying to do upgrades, it just doesn't quite work. So my recommendation, at least, is to try to break that down into smaller chunks. And so what I ended up doing was doing precisely what we're about to talk about today, or what I'm about to show you, is break it down into small chunks. Let's create the EKS cluster. Let's go ahead and create the IAM users or IAM roles separately, and think of these as different atomic steps, perhaps, even though they're not really atomic. But if you think of it like that. And then the next step might be create a node, create the launch template, then create the node groups, and then break each of those into an activity. And then suddenly you've got a pretty resilient way to provision infrastructure, and you got to take advantage of Terraform and its provider ecosystem. Now you might be wondering, okay, so if I'm breaking up this into a bunch of small chunks, why am I not just invoking each API call for those small chunks as a separate activity? That's a good question, and that's totally a possibility. However, there are in my experience, there's been situations where the Terraform provider will handle certain edge cases that are specific to one endpoint of the cloud provider. For example, I believe, and I could be wrong about this, that the creation of an initial VPC, I believe it like deletes some default security group or adds one, or there's some stuff that goes on there, and that's very nice. And you can think all the mileage that has gone into this rich provider ecosystem you get to take advantage of. So with that said, let's jump into a demo. Time check, Sean, how much time do I have for this demo?
Sorry, I was playing some sounds. I think you're good for like about 10 minutes.
10 minutes. Okay. Yeah. Well, let's give this a try. So what we're actually going to do is we're going to provision some resources. So I'm not blowing smoke here. We're going to go ahead and jump into some code. So what we have to start off with, and I'm going to blaze through this first part because of the time constraint, but we've got, connecting to temporal, we've got, connecting to the worker, the appropriate task queue. You can look up our examples about how to do this and even take this repository and run with it because it has a Docker Compose, and I've already Docker Compose created everything. And so what we have is a localhost port 8080, default namespace, nothing going on, right? So we've got a worker here that we can launch. We're about to launch, and if everything goes well and I didn't mess this up, then you know how it goes. Demos. We're going to start creating a VPC. So, and what I'm going to do is I'm going to kick off this workflow, and we're going to let it go, and we're going to talk through it. Just so you also are aware, I've got my AWS account here with no VPCs in it, no subnets. Oops, sorry for the zoom there. And we've got an S3 bucket that we're storing state in. And you can choose whatever state you like, your backend. You don't even have to do any of this on AWS. So let's go ahead and create something. So going back to the VPCs, we're going to keep that up. And I'm going to kick off a workflow here, and I should have an input available. And we're going to do this, you can do this, build your flavor of UI or whatever. Or if you just want to, kick it off with the tcuttle command. And let's see. So we've got the task queue that we saw on that first, on the main function, the actual workflow we want to kick off, create demo network workflow. And the workflow ID, demo network, whatever you like. The idea here is just that, one workflow with that ID will be running. And then, unless I messed up, hopefully I didn't mess up the new lines here and this actually runs, but we've got, demo VPC to be created in US West 2 with this CIDR block. And then we're going to create subnets across 2 availability zones. And let's go ahead and kick that off. Cool. So started a workflow with this ID, as you saw, and the run ID is CDB. Let's go to temporal, and I don't know if am I running the worker? Yes, maybe. Well, we're going to find out. So am I running the? No, I'm not running the worker, which is good. So if we click here, we're going to see, oh, maybe I was. Oh, yeah, I'm sorry. Yeah, I got a little confused there. So yeah, the worker's running it, picked up that workflow, created the VPC. You can see the output from that workflow is a VPC ID, 00BBB7B. And if I go over to AWS, my hope is that if we refresh this, we're going to see a VPC, and we do. It's named Demo VPC as we had wanted. And then if I refresh this again, we should see the create subnets activity completed. Go back to the actual top front page, and we've got a completed workflow. So in this workflow, we created the VPC and we created the subnets as two separate activities. And we're going to go back here to the subnets. We'll see that we've got subnet A, subnet B, with their different CIDRs that are cross availability zones. And so that is the state. Here's the state. We'll see that we've got two Terraform state files, two different activities. And we can jump into those and look at the details, but it might be better to go look at some code now. So let's go into, let's kind of trace the path here. So we started the worker, we've registered some workflows, and I'll jump into that. We registered workflows to create our demo network, the activity to create the VPC, and an activity to create subnets. Whoops, didn't mean to click that. Okay, so let's jump into the actual workflow. So this workflow, and ignore these really short timeouts. I was doing this for demo or for testing. You can pick whatever timeouts feel right, but it's important to pay attention to the heartbeat timeout and your retry policy in general. Moving on, we're going to create the VPC as an activity. The input for that will be, the name, the region, CIDR block, subnets. And then we're going to create the subnets, and then we're done with the workflow. Now, this is all great. You can't really tell that any of this is, Terraform yet. So let's jump into creating the VPC. So the actual activity is where you start seeing some idea of Terraform. And I think if you think of activities like your implementation, this could be a Terraform thing, this could be an SDK call, this could be anything. So this is where the nuts and bolts happen. This is where side effects occur. So what we're going to do in order to try to make this idempotent is we're going to look up that VPC by its name. So under this function is just a call to using the AWS SDK to list, to describe the VPCs with that name. And if it finds it, returns it. And that gives us the opportunity to import that VPC into our state. Why would we do that? Well, if for whatever reason our state does not get uploaded to S3, network error or something, this allows us to get a retriable activity. So for anything that you can, that if, for example, the create had attempted again, you want to definitely import that. And sometimes this is actually nicer than going out and looking at the AWS, like going to do a fetch against AWS. Sometimes the names are derivable, meaning like they're just a known value. Like let's say it's the input you gave, cluster name / EKS. But in some cases, AWS generates a name for you, in this case, a VPC ID, that you have no idea and can never know unless you go look it up. So we're going to import that VPC. Then we're going to create this TF activity. The TF activity is the thing in this particular, in our demo that understands Terraform, or sorry, understands heartbeating and activities. And it's responsible for like sort of wrapping this Terraform workspace. And so if we go back to our picture here, we've got this Terraform activity wrapper or workspace wrapper. Then we've got the workspace, which extracts Terraform from the embedded file system and prepares the variables and everything. So this section here, where we actually go to apply the Terraform, will do the extracting the Terraform files and getting AWS credentials and providing the variables to that file, to that run. So you're like, okay, where's my Terraform? We've been talking about Terraform, but I haven't seen a darn lick of Terraform. So if we go to actually our Terraform files, the way I've broken this down is that we've got our Terraform files here, and the VPC creation is here. It's very simple Terraform. That's one of the things I really love about this. You can imagine this looks a little bit more gnarly if you're creating types and structs and everything in whatever language. But with Terraform, it's very nice. You can just use this declarative language, get some good, nice autocomplete, and it's good. So, and then the variables that you want to input and the outputs you want to get. So given your inputs, given your outputs, and everything in between is Terraform and Terraform providers. So this uses
Joe, just to wrap things up here as well. One of the things that you also mentioned was we do testing as well, right, on inputs and outputs.
Yes, we do. It's important. So part of like making this, it's not just a black. It's kind of a black box when it goes to running Terraform right now. But what we try to do as best we can is it tests that we input the correct inputs and ask for the correct outputs. So, and then, then kind of it's off to the races what happens inside of the actual Terraform, which is kind of a blind spot, but with good testing and good integration testing, that kind of works itself out. So the embedded file system here uses the Go embedded file system to include the Terraform files in the binary. This is one of the big things that people are concerned about is like, well, where do my files live? Like, I got to build them into my Docker image. What do I do? Well, in this case, we're using Go's embed FS to actually embed those Terraform files into the binary, which gives us the benefit of the code matching the Terraform. And everything else that comes with, the Go single binary thing that we've all probably loved to some degree. So the Terraform activity, as I said, is just a simple wrapper that handles heartbeating. And so if we go into the heartbeat, we'll see here that we just begin heartbeating in a Go routine, and we listen for the activity to get canceled or the context to get canceled, and in which case it would cancel the heartbeating. Welcome to go check this out, dig into it in a little more detail. But just so you know, that's what keeps it so that we could run this possibly long-running Terraform. All right, the actual execution, probably not worth going too deep into, but what's important here is that we give the thing that was tricky, I suppose, in this whole experience was giving Terraform the ability to shut down gracefully, all right? Because I said, we've got this thing that we want to be able to run idempotent. We want to give it the best chance of being idempotent. And so we want to handle signals. So if we get a SIGINT to the process, we want to forward that on to Terraform, and Terraform then has provider sub processes that it needs to communicate with. So there's like this process tree that needs to be handled in order to terminate gracefully. So there's some cross-platforms-ish stuff going on here with with how we handle when the parent dies, on the parent process being Terraform, when that process goes away, what happens to its children, and whether they get disowned or there's all that kind of stuff that has to be handled here. But the thing that's important here is that we're handling signals and we're giving a good opportunity to shut down. So in our output, what we didn't get to see was what happened. So when we ran that activity, I'm going to scroll to the top here. We did the create VPC activity, and for now, I'm piping all of the output from Terraform just out to standard out for this process. And you can see here that it's like, okay, I'm going to create a VPC. Here's what I'm going to do. It says I plan to add one. It creates the VPC. Here are my outputs, and then it goes to the next one, which is our subnets. Our subnets activity then, says, okay, I'm going to create subnet in US West 2A and US West 2B and create those, and then we're done. So this wouldn't be a complete demo if.
Got to give you a final time check. Sorry.
Oh yeah. So I'm just finishing.
There we go.
Yeah, so this would be a complete demo if I didn't kill everything that we just did, right? So let's go ahead and destroy. And where is my... So now we got the create, we got the destroy, and before we know it, we should no longer have, let's see, resources in our VPC is gone. So we got creation and we got the cleanup, and cleanup's almost free. So happy to answer questions or anything offline. Check out the GitHub repo. I don't know if I shared that yet, but that is...
I shared it for you on the chat. Yeah.
Right there.
Yeah.
All right. Thanks.
Joe, that was amazing. Thank you so much. And sorry for the type checks. But yeah, that was awesome. Round of applause for Joe, everyone. And that was a really great overview of how we do infra automation. I think it's something that we're pretty proud of. And it's something that we took a while to evolve towards. Yeah, thanks, Joe. All right, so next up, we're going to have the learning paths team. We're going to run long for this one. So if you can stay with us, otherwise, we'll separate this out and post it as a recording. Rylan, do you want to kick it off?
Yeah, thanks, Sean. And I'm sure Joe will be happy to answer questions in Zoom chat. So if you have any questions about what Joe was talking about, please do that.